Alright students, today we are going to cover the last section of chapter 12, which is over similar solids. That can be any three-dimensional shape that is either a cylinder, a cone, a pyramid, or a sphere. All the shapes that we have discussed. It is not just limited to the ones I mentioned, it's all of them. Okay, so remember, similar means when we're in two dimensions, it's the same shape, but not necessarily the same size. So here I have two cylinders for you, and they are the same type. They're both cylinders, and they have the same scale factor. So here that's going to be 4 feet for the diameter. This is going to be 8, so 2. It's times 2. Here that's 6, that's 12, so that's going to be times 2. So these are proportional. So it says two solids that have the same type with equal ratios, that's supposed to be ratios, of corresponding linear measures such as heights or radii. Okay, so that's what makes it a similar solid. Alright, our theorems, you'll recognize this one from the previous lesson. It says that similar solids theorem, if two similar solids have a scale factor of A to B, then corresponding areas have a ratio of areas is squared, so this would be A squared to B squared. And this is the part that we're adding here. This is the new part. The corresponding volumes have a ratio of A cubed to B cubed, since volume is measured in cubed units. Alright, so to help us understand that, we're going to go through this example here. We have a smaller pyramid and a larger pyramid, and we're going to find all of these details here for each one. And then we're going to compare them down here. Alright, so first we have the perimeter of the base. So I've got the side length, remember it's a square. So the side length is 6. 6 times 4, that's 24 centimeters. The slant height goes from the top over to the side here, so that's going to be 5 centimeters. And the lateral surface area, that's going to be 1/2 the perimeter times the slant height. So you take the perimeter and the slant height and you multiply those together and you divide it in half. So 24 times 5, that's 120. When you cut it in half, that's 60. So my lateral surface area is 60 centimeters squared. Now that's area, so you have square units. Area of the base, that's a square. 6 times 6, that's 36. Total surface area, remember TSA, that's equal to your lateral surface area plus, in this case we only have one base because it comes up to a point, so plus your base. So you add these two together, you get 96 centimeters squared. Now the height I don't know because they didn't give that information to me. Remember, the height is the segment that joins the center of your base to the top vertex. It's that segment here, and that segment is perpendicular to the base. So it forms this right triangle. Now it goes from the center out to the side, so it's going to be half of this side, so that's 3 centimeters. The hypotenuse is going to be the slant height, which is 5 centimeters, and this is h. Now, if you don't recognize Pythagorean triples, go ahead and use Pythagorean theorem, the a squared plus b squared equals c squared. But if you already recognize that this is a Pythagorean triple, then you would know that this is equal to 4 centimeters. That's a 3, 4, 5 Pythagorean triple. Okay, so here, that saves you time if you can memorize just the easy ones. Okay, 4 centimeters. Volume. Volume, folks, remember, is 1/3 the area of the base times the height. Well, the area of the base is here, 36. The height is here, 4. 36 times 4 divided by 3. 36 times 4 divided by 3 is going to be 48 centimeters cubed. Alright, so we have all the components for the smaller square pyramid. So now we're going to do the same thing for our larger square pyramid. Find the perimeter of the base. Each side is 30, 30 times 4. That's going to be 120 centimeters. Find the slant height. There it is, 25. Now, just like we did above, we're going to say that the lateral surface area is 1/2 the perimeter times the slant height. So you multiply these two together, and you divide by 2. I get 1,500 centimeters squared. The base, that's a square. 30 times 30, that's 900 centimeters squared. The total surface area, remember, is to add those two together. So that's going to be 2,400 centimeters squared. And just like the one above, we don't know the height. Okay, so I'm going to draw the height. That's going to create a right triangle where this is 25, and this is going to be half of 30, which is 15. There's my height. Again, you can use Pythagorean theorem to find this, or if you recognize Pythagorean triples, this one is divisible by 5, and this one's divisible by 5. So this is going to be 3 times 5. This one is going to be 5 times 5. So I see the 3 and the 5, so I'm suspicious of the 3, 4, 5. So this one would be 4, and since we multiplied each one of these by 5, we would have to multiply this one by 5. So that's how I get 20. And that will save you some time if you can recognize it. If not, then just make sure that you use Pythagorean theorem. Volume, again, that's going to be 1/3 the area of the base times the height. The area of the base in this one is 900. The height is 20. 900 times 20 divided by 3, I get 6,000 centimeters cubed. Okay, so now we're going to compare this section with this section. Units. Units squared and units cubed. The characteristics that had just units are going to be A and A, B and B, because they had both of those were centimeters, and then F and F, centimeters, centimeters. Units squared, that's going to be C and C, they're centimeters squared, D and D, and then E and E. And then centimeters cubed, that's going to be the G and the G. Okay, so to compare these, I'm just going to set up a ratio for comparing A to A. That's 24 to 120. If I reduce that, I should get the same thing as when I compare B to B. 5 to 25. And then F to F, that's going to be 4 to 20. Now, reducing each one of these, when you put it in your calculator and you hit that math enter, you should get 1 to 5. So it's a 1 to 5 ratio. So you can write 1 to 5, remember, or you can write 1 over 5. Okay, so what that means is that my A is 1 and my B is 5. Okay, now C. C is 60 to the C, which is 1,500. D is 36. And D is 900. And E is going to be 96. And E is going to be 2,400. Now, when you reduce each one of these, in my calculator, I get 1 over 25. So that's a 1 to 25 or 1 over 25 ratio. Again, that's A squared, that's 1, is 1, and B squared, that's 5 squared, is 25. Okay, so my A squared and my B squared. Okay, the last one, That's going to be 48 centimeters cubed over 6,000 centimeters cubed. When I reduce this, I get 1 over 125. Well, that's a cubed, which is 1, and b cubed, 5 to the third power, is 125. So it's 1 to 125, or 1 over 125. And it doesn't matter if it's the radius that you're using for a cylinder, or the diameter that you're using for a cylinder, or the height, or the slant height, or a side. When you do this, you should get the same ratios. That's what this theorem is about. All right, let's move on to page 2. On page 2, we're going to do an example of a sphere. All right. So here, notice that they're asking the question just a little bit differently. It's the same information, but here they're not asking for a ratio. They're saying, how many times is the radius increased from sphere A to sphere B? So how many times bigger is it? Because see, sphere A, sphere B, it's increasing. Okay, well, the radius of this one is 6. The radius of this one is 2. When you reduce that, that's 3 over 1, or it's 3 times bigger. If I take this small one and I multiply it by 3, I get the bigger one. Surface area. Remember, surface area is 4 pi r squared. Okay, well, 4 times pi times 2 squared. 2 times 2 is 4. 4 times 4 is 16. So that's going to be 16 pi units squared. This one, 4 pi 6 squared. 6 times 6 is 36. 36 times 4, that's 144 pi units squared. All right, number 3. How many times larger is the surface area of sphere A, 16 pi, compared to the surface area of sphere B, which is 144? So we take our 144 pi and divide it by our 16 pi. The pi's cancel out, so 144 divided by 16, I get, that's 9 over 1, or just 9 times bigger. All right? Here, find the volumes of the spheres. Okay, well, that's going to be, volume is 4 pi r cubed divided by 3. So 4 pi 2 cubed divided by 3. That's going to be 8 times 4, 32. 32 pi divided by 3, and that's going to be, let me move this over. It's going to be units cubed. I'll just write the formula over here. This one, that's going to be 4 pi 6 cubed divided by 3. When I plug that one into my calculator, I get 288 pi units cubed. The next one says, how many times larger is the volume of sphere A to the volume of sphere B? Okay, well, you take this one here, the 288, and you divide it by this one here. Now, that's a fraction, so you have to put it in parentheses. 32 pi divided by 3. Pi's cancel out. When you plug this into your calculator, make sure you use parentheses. And when I plug it in my calculator, I get 27. It's 27 times larger. Okay, so next I see ratio of the sides. Well, that's ratio of the sides or ratio of the perimeters, but we're talking about like the radius. So that's, they're not saying small to large or large to small, so it could be written as 1 to 3 or 3 to 1 because they didn't give you a direction. Ratio of the areas is either going to be 1 to 9 or 9 to 1. Ratio of the volumes is going to be 1 to 27 or 27 to 1. Okay. Alright, next. Solve each problem using surface area and volume formulas of a sphere. Use the pi key and round all answers to the nearest tenth. Okay, well, first of all, I'm dealing with volume. And they tell me what my volume is. Then I read on, it says if its radius is increased 3 times. So there's an increase, so my sphere is getting larger. And its volume, now remember, 3 times means that's my scale factor of 3. If it's going to be volume, that's going to be 3 cubed. 3 cubed is 27. What is the volume of the new sphere? Okay, so I'm going to have a small sphere and I have a large. If I have 1 unit in the small, it's going to equal 3 units in the large because it's increasing 3 times. So if my volume is 1 unit in the small, then it's going to be 27 in the large. Okay? So here, all I have to figure out is, what is 31.57? Is it the large or the small? We'll see how it's increasing here. So this one's going to be the small, 31.57. So that means I'm looking for the large one. I'm going to take, since this is volume and this is volume, I'm going to compare these. You have to compare volume to volume. You cannot use the 1/3. If you do, you get the wrong answer. Set up your proportion. 1 over 27 equals 31.57 over x. And you cross multiply. When I do that, I get x equals the 27 times the 31.57, which equals 852.39, but they asked me to round to the nearest tenth. So if I don't read instructions, then that means that I'm not going to get the right answer. So that's 852.4, where's your label, centimeters cubed. Alright, there we go. Alright, the next one. The next one, my volume of the sphere is this if the radius is multiplied by a scale factor of 1/4. Now remember, this is greater than 1 and this is less than 1. When it's greater than 1, it's increasing, but when it's less than 1, it's decreasing or getting smaller. So I take my scale factor, 1/4, and I cube it because of volume. And then I get 1 over 64. Okay, so my small, what that means is 1 unit in the small would be 64 in the large. Okay, but here's the tricky part. Remember that you start off with your original. Your original is the large one. It is shrinking. So when you set this up, you want to put this one down here, 1039.64. And then you're going to find the volume of the smaller one. So set up your proportion. 1 over 64 equals x over 1039.64. Cross multiply. I get 64x equals 1039.64. Divide both sides by 64. You get x equals, that's going to be 16.244375. But remember, you want to round to the nearest tenth, so x is approximately 16.2, get your label, feet cubed. Alright, the next one we're dealing with surface area. Now remember, surface area is not cubed, surface area is squared. So the surface area of the sphere is 17.8. If the radius is increased, okay, so it's getting bigger. So we have, this one is the small, and it's going to be getting bigger. So we take our scale factor, which is 1.8, and because it's area, we square it. That's going to be 3.24. Alright, so here's my small, there's my large. 1 unit in the small is going to be 3.24 in the large. Okay, that's the small one, remember, so that goes up here, 17.8 x. Alright, so we want to cross multiply. Set up my proportion and cross multiply. I get x equals 3.24 times 17.8. That's going to be 57.672, but round to the nearest tenth. That's going to be 57.7. And of course that's going to be centimeters squared. Last one. The radius of a sphere is 4 times as long, so that's my scale factor than the smaller sphere. How many times greater is the surface area of the large sphere? Surface area. That means squared. So that's going to be 16 times greater. And they didn't ask me to find the surface area of the new one. They didn't give me the surface area of the smaller one. So that's all I have to do is 16 times greater. Okay, folks, you're going to do the check for understanding page, which looks very similar to the page we just did. So I'll be expecting this to be done when you come to class. All right, folks, that's it for notes 12.7.